So the point 5, -2 is locating the standard position angle. So I'm going to just find that point on the circle. So I'm going to go 5 over, about 2 down, somewhere around here. And again, we're just looking at the proportion of 5 and 2. And that's locating an angle here. Okay, I'm going to draw my little reference triangle here and putting in the positions. Okay, so it's 5 and -2. So the angle, in the first thing it's asking for is a radius, so we're going to use Pythagoras. And since we're given two sides of the triangle, we want to leave this in exact values. So we're going to do 5 squared plus -2 squared square root, and that's going to be square root 29. So square root 29 represents the radius, and we want to use that exact value. Then using these exact values, we're going to give this values for sine. So sine goes with the y. So it's going to be -2 over root 29. Cos goes with x. So 5 over root 29. And tan is our slope. It's a slope, negative slope, because it's sloping down. So -2 over 5. Okay, and then finding the angle theta. This is where now since this is not a special triangle, we need to use a calculator, and we're going to introduce decimal values into this problem. Okay, so when we solve for theta, I'm going to write it in its arc form, or the inverse form. So I'm going to just use maybe the tan in this case. Okay, we could use tan, cos, or sine. So I'm going to use the inverse tan. So we have inverse tan of the ratio. The input is a ratio. The output is my angle. Okay, so when I do the arctan, -2 over 5, I end up with -21.80 degrees. Okay, so this is going to be -21.80 degrees. Okay, so looking at this, we have to make sure that we have the right quadrant. So this angle is in the quadrant 4. The theta that we solve for is also in quadrant 4. Now there are times where you will be asked to find the positive version of that angle. Okay, so I want to have the same position, but the positive. If I were to write that in the positive form, I have to do 360 minus the 21.80, or more accurately, we should really say the position -21.80. We're going to start here and add 360 to that. Okay, and so we end up with 338.20 degrees. So that's going to be our coterminal angle, and that's a positive version of that same position. Okay, so we do have to consider that we have to make sure that this is in the right quadrant, because we've seen in the past that depending on the ratio, depending on the position, sometimes we might want to have the other angle that represents the same slope. So remember that we use the tan. So the tan is slope, and that same slope does have a different position over here. Okay, so we have to make sure that we're not finding that position and we're finding this position right here.